This is our first day of talking about it. We'll do a follow-up to this lesson tomorrow that's very short. Basically, we're just going to go in the reverse order. I will, for those of you, some of you might feel comfortable just being able to do tomorrow's assignment without needing the lecture. I'll show you a little trick in terms of doing and going in reverse. So we're going to take a binary number and turn it into its decimal number. So what is the number as you know in its decimal form, like 586 and stuff like that. And that's what we're doing today. And then tomorrow we'll give you a number, and I'm going to ask you to write it in the binary number system. So just as we're in terms of talking about the decimal number system, which is one of the easiest ways to write numbers and how we work with it, and doing the kind of calculations and additions and working with numbers the way we did it. We talked about, in an example, 586 is the same thing as 500 plus 80 plus 6. And in regards to really understanding the decimal number system, it is 5 times 10 to the second plus 8 times 10 to the, that's to the third, so apologies, 10 to the second plus 6. No, I was right. Who told me I was wrong? Me? Oh, okay. Second, first, 10 to the 0. This is basically what we work with. And if we wanted to write with any number, the idea here that we need to understand, and we talk about it as decimal, deca, as a reminder, meaning 10. The numbers that can go through here are 0 through 9, 0 through 9, 0 through 9. So this is very helpful for us in the way we've learned our number systems. All right, and in working in the way we are, it is very helpful. But there are other number systems that are very useful. The main premise here is we can actually make a table of our number system where this, and we can, and yes, you can go negative. So, and let me, for example, let me put a decimal point right here. This would be 10 to the negative 1, 10 to the negative 2, 10 to the 0, 10 to the first, 10 squared, 10 cubed. Within each of these spots, there are, based on the idea of the decimal number system, and as I've stated above, there are 10 possibilities that can go within each of these numbers. So if I write like 5, 8, 6, 0, 3, 9, all right, we know this number as 5,860.39, and that's the number in its decimal form. It's 10 cubed plus 10 squared plus, or 6 10 to the first plus 0 10 to the 0 plus 3 10 to the negative 1 plus 9 10 to the negative 2. And this is how we do our number system. I'm not going to go too much into it. There's a lot of history that you can really learn about in just regards to why these number systems and the decimal number system works in more detail. But this is what we are doing. For each of the placement values, deca, meaning that we're using base 10. So decimal, referring to that we are using base 10. We are breaking up And so the idea here is that we're breaking up and we're dividing every feature into 10 possibilities. So you can, if you think about this in application, basically you have 10 different settings for everything. So think of those like, and you have those like brightness levels, you have 10 different settings. So with the 10 to the negative 2, you can put 10 different settings, 0 through 9, 10 different settings for 10 to the negative 1, 10 different settings for 10 to the 0, 10 different settings for 10 to the 1, 10 different settings for 10, and so forth. Everything has 10 settings. Well, when we try to move to computers, the decimal number system is not practical. All right, it's not practical, and something that you can talk a lot and learn about is that computers use electricity / voltage to work. Now, we could talk about power consumption. We can go in terms of how if we try to set things with decimal number systems, there does become a power usage of like things like overheating and so forth. It just becomes very, very difficult. You might have something that's very low voltage. So, for example, point. You have something that's very low voltage, and if you try to divide it into in terms of how much voltage it is accepting, it becomes very difficult to get those values so that we don't get mistakes, such that can you tell the difference between 0 volts and 1 volts? That's a pretty easy catch. But catching the difference between 0.1 volts and 0.2 volts versus 0.3 volts of electricity and how much is being sent becomes much more difficult. As such, you would need to get something that's much, much more powerful. Instead of 1 volt, you have something that's 100 volts in order to be able to, identify those differences. Now, there's a lot more. I am by no means an electrical engineer. But in terms of basic understanding, computers, when we talk about this idea of settings, and you have this switchboard, or it's not even a switchboard, but what can go in terms of each one of these. When talking about this idea behind electricity and voltage, it's overwhelming, and it's inaccurate at times to be able to try to send something with 10 different settings. All right, I have 10 different choices to go right here. I have 10 different choices to go right here. I have 10 different choices to go here. It doesn't work when we talk about electricity. So computers cannot handle, in layman's terms, 10 settings for options, basically. As such, therefore, computers utilize binary. And with binary, you have the choice of 0 or 1. And we refer to these, and when there's only 2 settings, we can think of this as off and on. So we have little switches in terms of choices. Like we can turn this one on or we can turn this off, on or off, on or off. And basically, instead of saying like this is 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9, it's either 0 or it's 1. It's either you're going to send something. And so what computers do is that computers are set to not calculate the voltage sent to each, I'll call it switch. Voltage. And when I say voltage, I kind of think about my voltage electricity. Voltage is either sent on or not off. And the values 0, 1 represent this. So in terms of trying to figure out, is this a 0? Is this a 1? Is this a 2? Is this a 3? Is this a 4? How much electricity is it trying to send us? And if you think about the calculation, or if you try to think about it in terms of if you try to measure something, is this 1, 2? Is this 0.1, 0.2? That takes power in order to do. And so what computers, and what was realized with computers, is that instead of doing that, either something is being sent or it's not. And now you can think about it as just sent or not sent. And that's what the basic concept of binary is. Now, bi means what? Deca meant 10. What does bi mean?
It was 2.
It means 2. So with binary, we're using base 2. So, and we can still create, thank you TJ as well, we can still create every number and options as we did. So instead, when we do the table, or when we were doing those tables, and for our purposes, we're not going to go to decimals or less than 0 type of ones. We could think of this as times 2 to the 0 times 2 to the first times 2 squared times 2 to the third times 2 to the fourth. And the choices that can be in here, the choices are either 0 or 1. We either turn the switch on or we leave the switch off. Now, this is one way to represent the table, but what is 2 to the 0?
2.
No.
0.
No.
1.
It's 1. So this is the same thing as times 1. What is 2 to the 1?
2.
What is 2 to the second power?
4.
What is 2 to the third?
4. 8.
8. And what is 2 to the fourth?
16.
Now, when they talk about something, when the first video games were being created, a lot of them were like 8-bit or 4-bit. Like in the very first games, the video games, they were talking about bits. And when they were talking about bits, they meant this. So if something was 4-bit, basically this is what was in terms of every little coloring placement, how many different abilities, possibilities that they have. And so when the concept of bit came with the computer programming, and it was here. I remember the first time 64-bit came around, or 32-bit came around. I think it was like the Sega Genesis was the first one. It was like 32-bit, and you can actually see and you can make out what the actual character was rather than just try to like squint. And I got your piece. Nintendo, the very first Nintendo was 8-bit. You know, Super Nintendo, Nintendo 64, it became 64 bits. So that can go all the way to 2 to the 64. Um, which
You know what I thought the bits were?
hmm
Because one of my life objectives is to become a video game developer. I
hmm
thought the bits were like the graphic, like how many pixels it shows in screens.
it is. So
It is.
yes, and it comes from this concept though. So it does when we're talking about pixels, that's basically what it is. But the possibilities come from, like, so for something like 64 bits, you can have those amount of pixels, and like, don't put me in terms of 100%. I would have to do a little bit more background and information, but that is basically what it comes from. So basically, how many switches you can have, and there is a correlation between the pixel densities and so forth. And these days now with the new computers, I don't know what the amount of bits are, but it's like ridiculous now in terms of how many possibilities you have, and you can go in there and have all of these settings, and that's why it takes so much computing power, especially with these new video game systems. Basically, you have, yes, it's still all switches, 0 1 0 1 0 1 0 1 0 1. It's either on off on off
Oh,
on off.
it's like in the millions now.
Yeah,
I
exactly. and
remember.
and yeah, so and what the computer still needs to do is it still needs to basically understand and take all those zeros and ones, and it programmed it to like a color, right? So like that little space and color is based on this, and you can get very, 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 very detailed, especially with like the pixel densities and stuff like that. It's based around that. So if you're interested, so computer programming, all things that are built around computer programming, computer engineering, electricities, it's all based in the binary world. Now, when we talk about these numbers now these are the numbers. So if this is on, that's a 1. If this is on, that's a 1. If this is off, that's a 0. Off, that's a 0. And on. So you can turn these switches either on or off. And if they're on, it means we have 16 plus, in this case, 0 plus 0 plus 2 plus 1. And that would give me 19. Now, when I say on off, what I really mean is either a 1 or a 0. A 0, 1, and a 0. So for each of these spots, we either turn it on, off, on, or off. So what we just learned right now, and I'm going to put a little bit more, is the binary number 10010 refers to these switches being either on or off, and we will actually usually denote these to know that we're talking about the binary number system. We'll put a little small 2, and that 2 just tells me that we're working in binary, so that this, you don't go, oh, that's numbers 10,010. No, it's 10010, and we just can see now that this is the same thing as 1 times 10 to the fourth plus 0, or sorry, oops, not times 10, 2 to the fourth plus 0 times 2 to the third plus 0 times 2 squared plus 1 times 2 to the first plus 0 times 2 to the 0. And this number is the same thing as 16 plus 0 plus 0 plus 2. Oh, oops. I was wondering, I did have a mistake there, and I was like, that was really confusing me. Apologies. That right there should be a 1 right here. Sorry about that. And as such, this should be a 1 right here. Apologies. Plus 1, which is 19. And we're going to take some more practice, don't worry. I'm giving you a little bit more background and anything. So 10010 in binary is the same thing as 19. And that's going to be your main goal for doing your homework tonight. Now, I am going to ask you to show me this right here. Or you can show me this. You know, I want you to know that what you're doing. And then the final step is to show me what that number is, and that number is 19. So you got to think about these as a bunch of on and off switch. It's 2 to the 0, and how many, you got to count from 0 and go. So there's, in this case, there was 5 places, and so that first one is going to be, you're always going to have to go -1. All right. So when going this way, the biggest number, and I want to note here, if we were to turn all of these on, 1 1 1 1 1, okay, what is this number? So if we were living in a 4-bit world, okay, 4-bit world, how many different possibilities could we utilize? Okay, well, there are 5 place values, so you can, and it's often easier even to go backwards in here like that. So you always read from right to left. So you read right to left. All right. So this is, it's on. So it's either the first one is either a 1 or a 0. So it's 1 plus 2 plus 4, and it just doubles, plus 8 plus 16. Each of these switches is on. And what number does that give me? 31. So there are 31 possibilities in, and if you think about it like in color palettes or in pixels, there's a lot of different ways to talk about it in a 4-bit world. And you know what? And I could also be a little bit off here. You know, the 4-bit actually, you know, I got to do a little bit more background. Does 4-bit mean that this 4 and 16-bit meant right here? I'm not by any means an expert in the background yet, or I can't, you know, in terms of it. But there is a very strong connection, or the basis of the binary in bits and pixels and pixel densities, all comes from this concept of binary. Okay. So in your homework, this is what you're going to be doing. So, example, given the binary number, show as base 10 or base 2 and then convert to its decimal form. All right, so as you will see in your homework, so here's A. All right, and I'm going to give you the number. And the number I'm going to give you is 10110. Okay? So I want to show it these numbers as base 2. So if we go backwards, so this is the same thing as 2, because one times anything is just 2. So this is 2 to the what? Sorry. 1 times 2 to the what? Yeah, you know what? Let's go backwards. 0 times 2 to the 0 plus 1 times 2 to the first plus 1 times 2 to the second plus 0 times 2 to the third plus 1 times 2 to the fourth. And therefore this is what? Well, don't give me the final number. So what numbers do we end up using? Remember, everything is either a 1 or a multiple of 2. So 1, 2, 4, 8, 16. So really, remember, you just got to remember those 1, 2, 4, 8, 16, 32, 64, 128. And actually, I think that's where the bits come from. They added an extra switch so when they went to it. So it would be 16, good, plus that's 0, so it's not an 8. So it's next number would be a 0 plus a 4 plus 2 plus 0. So 0 plus 2 plus 4, that's a 0, and then a 16. And so that number gives me
22.
22. Now, like I said, you could think of this as a table, all right? So if you really just think of these as a table here, and you have the numbers 1, 2, 4, 8, 16, 32, 64, and then I give you the number, and the number is 0, going backwards, 1, 1, 0, 1. All right, so you always write it and you push it as far to the right as possible. This tells you in the table that the number is the same thing as 16 plus 4 plus 2, which gives me 22. So it's a bunch of on and off switches. On or off, on or off, on or off. So 10110 is the number 22. Questions on that example? Let's up the switches. Somebody give me some ones and zeros, starting with 1.
10010.
2 more.
11.
Okay, and this is in binary. So the question here is, what is this number? All right, what is, and the whole goal in the homework assignment is to turn this number into its decimal form. And that's your homework. That's what I want you to do. Okay, so 1001011. Okay, once again, think of this as the on and off switches, right? So going backwards, we have a 1 plus a 2 plus a 0 plus a, well, what's the next number going to be?
Will be 4.
No, because the 4 was a 0.
8.
So 8 plus a 0, that's where 16 would have been, plus a 0, that's where 32 would have been, plus
64.
64. So basically, and if you want to write them all the numbers out, you could also have done this as, you go, okay, 64 and 32 and 16 and 8 and 4 and 2 and 1, and then you can just literally cancel out which ones are off. All right, the 32 is a 0, so that closes off. 16 is a 0, that closes off. 4 is a 0, that closes off. And finally, what number do we get?
75.
So 1001011 in binary is 75, is the number 75 in decimal form, as we know it. And what happens in computer programming is that each of those possibilities, those 70, so 75 might represent purple, right? Or like a specific shade of purple, a specific shade of gray. So that's basically what happens. So when I am, now that I think about it, so when you get into something like 64 bits, that means there's 127 possibilities that you can do. So for each little spot, you can do 127 different possibilities for every piece of it. And the computer, and what was very, mind-blowing at the time, is that you had to have a strong enough computer processor to be able to handle those for all of the different parts of the screen. So 75 gets mapped to that one. So for that little pixel, 75 gets mapped. All right, and so what does 75 represent? So when you do like computer programming and coding, you will take if this is 75 at this little spot, the computer will look up what it's supposed to be. This needs to be this, and there you go. Now there's more to it, of course. So like Elian was talking about in terms of pixel density and so forth. But that's your homework. That's binary. You're going to take some stuff, and in some cases I have the 3, like 101, and then it moves up. I think the largest one is something that's like 64-bit like this. All right, so this over here, we would consider this 16-bit, 10110. That's a 16-bit binary. 1001011 is 64-bit binary. If you're really interested in that extra terminology. But basically, like I said, it's a bunch of on and off switch. The 2 to the 0, 2 to the 1, 2 squared, 2 to the third, 2 to the fourth, depending on how many 1001001. I know when you hear those, and maybe you've heard it on TV, and you're like, what are they talking about? That's what they're doing. All right. That's what I have for you today. Your homework is on Google Classroom. Tomorrow, we'll learn how to take the number 75 and how do we write that in binary. All right. So that's what our goal is going to be tomorrow. So how do we take that 75 and how do if I give you the number 75, tomorrow's class or tomorrow's purpose is to write it as binary. So your job will be able to write it as 1001011. Today, you're taking that 1001011 and turning it into 75 by just thinking about how the switch is. And tomorrow I'll show you how to go in the reversed way, and that'll be our lesson. All righty. Thank you, everybody.